Greetings hobbies, this is Artisanzofall, and in this video we're going to have a look at how we can find the size of an object inside geometry nodes. So we've got our standard cube to start with, and I'm just going to modify this a bit to make it a bit more of an interesting shape. So I'm just going to have variation on each of the axes, X, Y and Z, so that they're different sizes, just to make it a bit easier to see what we're doing and that we're actually using something that's got different proportions. Otherwise it could be difficult to tell if this worked. And then I'm going to Control and A and apply the scale. So before I begin, I just want to explain why we actually might want to do this. If you're perfectly happy with that already, then feel free to use the chapters at the bottom to just go straight to the description of how to do this. So I've opened the geometry node editor, and then let's just sort of demonstrate why we want to do this. So Shift and A, and I'm just going to bring in whatever, a cube, and we're not going to need the group input node, so let's just delete that straight off. So let's demonstrate why we're going to do this, and I'm going to bring in a mesh line just there, and then we'll connect that to the geometry, and we've got our mesh line here. Now, what's useful about mesh lines is that we can use them for a form of instancing, which is going to effectively make an array. I've got a video in the top right hand corner covering that, so you might want to have a look at that in a bit more detail, but just quickly I'm just going to bring in an instance on points, plug that in there, and then we can use our cube. I just bring that in as an object info node and plug that into our instances, so geometry to instances. And you'll see we've got that stacked on top of each other, and we can just use our offset on our mesh line just down here, and we can just drag that up until we've got something where it's about the right size so that we don't have any overlap, so something about there. So that's great. But if I then change the size of my object, so for example if I click on this, S to scale it down and Control and A and apply the scale, we suddenly get these big gaps between them which we might not want. We want this to stay as an array, so this doesn't quite work. What we want to do is be able to use this, and instead of having this size of the mesh line being determined by a fixed value, we want to be able to set it to, well, the height of this to effectively make an array. Now obviously you could just make an array, but sometimes we want to be able to do this in something like geometry node so that we can then go on to do further things. Let's just get rid of that, and we'll leave that up there for now, and we'll talk through how we can track this shape. So actually I'm going to move down there just so it doesn't cause any confusion, and we can come back to that later. So the first thing we're going to need is an object information node so that we can have this being tracked in our node group. In fact, let's just press F2 to name this as node group so that it's easy to see. And I'm going to just grab my cube, drag it in here, and we've got our object info node that's set to the cube. And if there were more objects in here, I could obviously change that out to one of the others. Now, frustratingly, this doesn't have any size information included in it. It's got the location, the rotation, and the scale, but that doesn't actually cover the size of the object. To do that, we're going to have to pull this out, and we're going to have to bring in what's called a bounding box. There might be other ways of doing this. If you do know one, do say so in the comments, but this is the way that I've found the easiest to do it. And if we just connect this bounding box to our geometry, and we can see we've got a replication of this cube. Now importantly, this is only replicating it as a cube because our original object is a cube. If our object wasn't a cube, then it's still going to create a cube, but with the same dimensions as that object. In fact, let's bring in a sphere. Let's S to scale that up, bring that to the side, and Control and A to apply the scale. So if we come back here and change this from the cube to being the icosphere, you can see it looks like a box. Not exactly the same, because it's a bounding box, not a copy of the object. Let's go back to our cube and let's delete that. So I just wanted to clarify that point. Now what's helpful about the bounding box is it has a minimum node and a maximum node. And you'll notice if you hold your mouse over it that it's got a point for the max and a point for the min. And the way this is working is that it's looking at this vertex that's down here in the bottom corner, and then this vertex in the top corner here. And what that allows Blender to do, which is quite cool, is it allows it to work out, well, the difference between these on each axis. So you've got your Z value there, your X value there, and your Y value there, just looking at the differences on each of those planes. So those 2 points and this vector line that goes between them allows Blender to work that out really simply. The problem is that we don't want it to work out all 3 simultaneously. We only want it to work out one of them in most instances. Except for we can get around that quite easily. If we just cut that, so I'm using Node Wrangler, so you can press Control and right click to cut. You just activate Node Wrangler in the edit menu and go to add-ons. And what we're going to do is we're just going to Shift and A, and we're going to bring in a math node. But importantly, it needs to be vector maths because these are vectors. And then to find the difference between any two numbers, well, the range between any two numbers, all we have to do is take the maximum and subtract the minimum. So now we've got this worked out, except for, well, this isn't going to help us at this point because it's still a vector. So we need to change this from a vector into the individual axes, and all we need to do is drag out and use a separate x, y, z. Once we've got that, this is going to work. We can find things on the x, the y, and the z. Now if we come back to our original situation of wanting to make a form of array that automatically updates, if I just bring that in here and want to calculate this on the z-axis, you'll notice that annoyingly the mesh line doesn't have this because it wants it as a vector, and we can't actually plug in this vector because it will change the line to be a diagonal. In fact, let me just show that so that this is really clear. So if I get rid of this and plug in the vector, you'll notice suddenly it gets the angle, so it goes from a corner each time because that's what the vector is trying to do. So in a slightly unfortunate way, we do have to use this separate x, y, z, and then in an odd turn we have to then move this, and then for the offset we need to use a combine x, y, z. I know it's the joys of geometry nodes, but what this allows us to do is it allows us to plug just in the z, but not the x, y, and z. So we've eliminated these being part of it. And now what that means is that we've got our array working perfectly, and if we change the size of this in any way, so if I scale that up and then Control and A and apply the scale, it will update that distance there so that we don't have a problem. And if I just S and Z to exaggerate that, and then Control and A and apply the scale, you can see that it is working. So sometimes you need to use this combine x, y, and z, but most of the time what you're going to want to find the size of anything is this set of geometry nodes, and then you can use the x, y, and z as you want. As always, I hope that's helpful and it gives you a new idea of something you can try out with geometry nodes, and we're going to be using this in a later video to do something really cool. So if you're not subscribed, do subscribe to the channel so you can stay tuned for that. Have a great day, guys.